Hi, welcome back. We're going to continue talking about the graphs of polynomial functions. And specifically in this video, we're going to talk about something called the end behavior. And in order to understand what I'm talking about here, let's just take a look at the graphs of some polynomial functions. So I'm going to let Desmos do some graphing for me here. And I don't really want us to worry too much about where these things cross the x-axis, so I'm going to turn off my axes so that we just have, actually I'm going to turn off, that's what I want, so that we just have a blank grid, and because I want us to not worry so much about the x and y axis at this point. So I'm going to just put a polynomial on here, and we'll make it a big one, 7x to the 5th minus 3x to the 4th plus 8x to the 3rd minus 27x squared plus 3. Okay, so here's what I want us to notice. This polynomial kind of makes an S shape, right? And if I make my leading coefficient negative, it makes that same shape, it just kind of turns it upside down. Interesting. Okay, let's try another one. Let's try y equals 6x, whoops, wrong, 6x, well, let's make it more interesting. Let's make it 0.1x to the 8th power minus 5x to the 7th power, oh, 6th power, that's better, plus 3x plus 3x. Okay, what happens? Oh, it makes this kind of weird, funky U shape. Let's change this. There. It makes that U shape, doesn't it? And what happens if I make this negative? It just turns it upside down. So let's talk a little bit about what's going on here. It turns out that every odd degree polynomial is going to have the same basic shape. It's all going to look something like this. It's going to make what I call the John Travolta. You'll have to go watch Saturday Night Fever if you haven't. And every even degree polynomial looks something like a parabola, makes a goalpost. Now, if, and how do you know which one it is? Well, you look at the degree of your polynomial. So all even degree polynomials will have ends that look like that, and there can be some weirdness in between there, but we're going to ignore that because all we care about is the end behavior, which means that as x goes to negative infinity, y goes to infinity, and as x goes to positive infinity, y also goes to positive infinity. Or they can also be upside down, just like parabolas can be upside down. So it might look like, and there might be weirdness in between there, but we don't care about that because we only care about the ends right now. Or it can be upside down, which means that as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to negative infinity. Now, how do we know the difference? Just by looking at the equation. Well, your leading coefficient is, remember, a sub n from that general form. We get this case if your a sub n is positive, and the upside down case if your a sub n is negative. Okay. Now let's talk about odd degree polynomials. All odd degree polynomials with leading coefficients a sub n are going to look like that x to the third. So they're going to look like, and there might be some weirdness in between here, this. Or they might look like, let's make that better. There we go. We're not going to worry about the weirdness in between. They might look like that. Which means that as x goes to negative infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to positive infinity for this first case. Or if x gets really, really big and negative in this second case, y is going to get really, really big and positive. And as x approaches positive infinity, y approaches negative infinity. Now, how do I know the difference? Well, we get, if our leading coefficient is positive, we have the left-hand case. If our leading coefficient is negative, we have the right-hand case. Okay. So we're going to come back in a second and talk about the zeros or x-intercepts of a coefficient or of a polynomial, and how we can find those if we have a polynomial in factored form.